Okay, in this example, it's another blast from the past. Two different pipes can fill a swimming pool. When turned on at the same time, they fill the pool in 8.4 hours. The smaller pipe alone takes 7 hours longer than the larger pipe to fill the pool. How long would it take the larger pipe to fill the pool? Does it make it more exciting if I inflect my voice? No? Oh, sorry. So let's name the unknown. I don't have a chart for this one. Let's name the unknown. And I think the last sentence helps you out here. How long would it take the larger pipe? Well, you call it X, but hey, let's call it T. And okay, how long? Let's include the units when we name the unknown. We're talking minutes, hours, decades. So it's number of hours, or just hours if you like. Hours it takes, and I'm leaving a word out. That's okay. We're still conveying meaning here. The hours it takes the larger pipe to fill the pool. Working alone, but I think that's implied, right? Okay, now based on that, in terms of T, can we get the amount of time it would take the smaller pipe? So third sentence. The smaller pipe alone takes 7 hours longer. So in terms of T, how long does it take? T plus 7. And then use ditto marks. That's the hours it takes the smaller pipe to fill the pool. It's really nice to see you guys write this stuff because it's going to help you understand. It really will. And then we know that together they take 8.4 hours, right? All right. Now remember what the technique is here. You have to turn everything in terms of a speed or a rate at which they do the job per unit of time, right? So let's start with the solid number we have. Together, it takes them 8.4 hours to do the job, right? And what's the job? Well, to fill the pool. So how much of the pool gets filled in 1 hour? In other words, how much of the job is done in 1 hour if it takes 8.4 hours altogether? Good. 1 divided by 8.4 is the amount of the, let me write it generically here, just because, so to look the same in all the problems you do, is the amount of the job finished per unit of time, so that's in 1 hour. So I've turned it into a rate, right? Now that's if they're working together. So I should mention that somewhere. That's if they're working together, right? Okay, how long would it take, say, the larger pipe? Then using that same idea of just taking the reciprocal to get it in per unit of time, how much of the job done is per unit of time. How long would it take the larger pipe? 1 over T. So 1 over T, I'll use ditto marks here, is the amount of the job finished in 1 hour by the larger pipe. Does that make sense? Okay, do the same thing for the smaller pipe. How much of the job does the smaller pipe get done? In other words, how much of the pool is filled in 1 hour by the smaller pipe? 1 over T plus 7. Ditto marks again is the amount of the job finished in 1 hour, and that's by the smaller pipe. Now, I write this much so that you guys understand the problem, because I think that's what it takes to understand these kind of problems. There's a formula you can use, but I don't mention it because it really doesn't involve understanding the problem if you do it that way. Now, if you want to write down as the least amount possible, I recommend writing all this down on the test, but at least show me this. Well, and you've got to name the unknown, so this too. So I guess the only thing you're allowed to skip is the second statement. If you have this, then I'll assume that you know the second statement. All these problems work the same way. Once you get that information, you just add a couple things together, set it equal to another thing, and that's your equation. So what makes sense to add together here? If they're working together, what are you going to add? you're going to add the individual speeds at which they work. And that should equal the speed at which they do the job together, right? And so what do you get if you do that? 1 over t plus 1 over t plus 7 equals 1 over 8.4. Okay. Now, I have a suggestion to make. Normally, decimals are easier to work with than fractions. I think most people would agree with that, right? I don't think that's the case here. But since you have to clear fractions, clear denominators, I think it'd be easier to turn 8.4, since it's a nice, it turns out to have a reasonably nice fraction. I think it'd be easier, fraction form that is, I think it'd be easier to convert 8.4 to a fraction so you can easily find the common denominator and do at least part of this problem by hand. So in that spirit, okay, 8.4 is what? 8 and 4/10, right? Or that's the same as 8 and 2/5. So what is the improper fraction form of this? 16. Oh, wait, 8 times 5 plus 2, 42/5. That's not the ugliest fraction I've ever seen, right? But you're taking 1 over that. So what's 1 over 8.4? It's the reciprocal, so you just flip this. 5/42. So the point of all this is I could change the right side to 5/42. And I think it makes the equation a little easier to solve in this case. Everybody see what I did there? Nothing too crazy, right? Okay, what do we do to clear the fractions? What do we multiply by? The LCD, what is the LCD of t, t plus 7, and 42?
42 times t plus 7.
That's how I would write it. 42t times the quantity t plus 7. Now remember, that entire quantity then has to be distributed to each and every numerator. Multiply each and every numerator by that quantity. But you might want to cancel as you go so it doesn't become a total mess, right? So from that first term, when you distribute the LCD, what's left? From the t's cancel, so what's left? Just 42 times the quantity t plus 7. Does everybody see that? What's left from when you distribute it, the LCD to the numerator of the second quantity? 42t, because the t plus 7's cancel, right? Okay, what's left on the right side? Yeah, the 5 was there originally, so that's not going anywhere. The 42's cancel, and then the t and the t plus 7, those factors aren't going anywhere, are they? So 5t times the quantity t plus 7? Does everybody agree with that? Okay. How do you solve an equation like this? What do you got to get rid of? Parentheses. All right, help me out here. I'll do the first multiplication on the distribution for you. I think 42 times t, I think, is 42t. But then you do the second one. What's 42 times 7? What is it? 294? I believe you. And then plus 42t. Okay, distribute 5t on the right side. What do you get? So 5t squared plus 35t. Do we have anything that cancels like that last problem? No, unfortunately not. So let's see. Let's do the 42t plus 42t first. What does that give us? So 84t plus 294 is equal to 5t squared plus 35t. Okay, what kind of equation is this? Quadratic equation, which means we should probably set it equal to 0, right, to start. It's my preference, and probably yours, to leave the a, in other words, the coefficient in front of t squared, positive. So let's move the 84T and the 294 to the other side. What do we have to do to accomplish that? Okay, subtract 84T, subtract 294. Minus 84T, minus 294. I don't always show my work, but sometimes it's nice to. Okay, so that gives me 0, I predict, on the left side. And then 5T squared. What's 35T minus 84? Okay, so minus 49T minus 294. Okay. This is another one of those equations. I'm not sure if it factors, and I don't really want to. I'm too lazy to try. Okay, I mean, if it looks like it, you know, if the numbers aren't too big, try factoring it. And there's several problems in the homework that are best solved by factoring. But this one, no, I think I just want to use the quadratic formula. So, okay, T is equal to negative B. What's that? So the opposite of negative 49 is positive 49. Plus or minus square root of B squared, right? So 49 squared. Well, technically it's negative 49 squared, isn't it? In parentheses, negative 49 in parentheses. Minus 4a, what's a? 5, and then c is negative 294. All over 2a, which is 10. Okay. So let me show you how I would run these through the calculator. So I'm going to remind you how to type this in all at once. Okay, obviously there's two possibilities here, and we're not sure that the one with the minus is going to be negative, so let's get two answers, and we'll cross out the one. I think one of them is not going to work. Probably the one with the minus, 49 minus the root, but let's find them both just to be sure. If you want to plug everything in at once in your calculator, type in a left parenthesis. I think parenthesis is the proper thing to call it, but nobody does, so I'm going to say parenthesis. And then 49, let's do the minus one first, minus square root of, all right, so negative 49 squared is the same as 49 squared, so I'm not going to waste the negative. Okay? Minus 4 times, okay, I can do 4 times 5. Is it going to be minus when the smoke settles? Yeah. So why not make it plus right now? And then 20, I can do 4 times 5 in my head. 20 times 294. And then you've got to hit the arrow and get out of that square root, and then close the parenthesis around the numerator, and then just divide by 10. And we get negative 4.2. Is that going to be a valid? No, t is time, right? So that's not going to be a valid answer. But I'm going to write it down because I'd like to see you write it down on the test just to show me you took the time to examine that situation. T is equal to negative 4.2. Now, there is a fast way then to get the one with the plus. Just go second function, enter if you have a TI calculator, and then arrow over and change that minus to a plus. I'll get there eventually. Plus. So, okay, so we get 14 for that, or t equals 14. I can't believe that turned out nice. Okay, so we get t equals 14. 14 what?
Hours.
Yeah, 14 hours. Now, let's make sure we've answered the question. How long would it take the larger pipe to fill the pool alone? Was t the time it takes the larger pipe? Yeah. This is where naming your unknowns pays off, right? Because you do all that work, you might forget what t stands for. It takes so long to do it, right? Yeah, we were just asked to find the time it takes the larger pipe, so we're done. What if we wanted to know the time it takes the smaller pipe? What would we do? Just add 7, right? It would take 21 hours. Okay. So to summarize, you could say, so it takes the larger pipe 14 hours To finish. To finish what? To finish filling the pool, but I'm just going to say to finish.